Today we are going to discuss about the problems on the D'Alembert's principle. As we know that the D'Alembert's principle used to make the body in a static, that is dynamic body will be, when we apply the D'Alembert's principle, the dynamic body will be in static. To convert that, we use the D'Alembert's principle. So first problem is a block weighing 1 kilonewton. The weight of the block is 1 kilonewton. Rest on horizontal plane as shown in figure. So the figure is given. Then we have to find the magnitude of the force P. It is the force P given required to an acceleration of 3 meter per second square to the right. That is, we have to find out the force P to move this body with acceleration 3 meter per second. The coefficient of friction between the block and plane is 0.25. So the given data, from that we will draw the first of all the free body diagram for this figure. Okay, so the free body diagram, that is FBD. We will draw the first of all the block. Okay, then the weight of the block is given as W is equal to 1 kilonewton. So it is given data. The force P, which is inclined with respect to x 30 degree. So it will be resolved into two perpendicular component. One is a horizontal, other is a vertical. Horizontal component is P cos 30 degree, vertical is a P sin 30 degree. Then the reaction generated, that is normal reaction, we consider at N. Then the body will be moving towards right side, therefore the frictional force at point of contact is moving, that is it will be towards the left side. Okay, then the body is moving towards right side. So to keep that body in equilibrium, we apply the D'Alembert's force or inertia force opposite to the motion of the body, that is M into A. So here M is W upon G. W is here 1 divided by G is 9.81 multiplied by the A. Okay, then now we will apply the equilibrium condition. The now body is under equilibrium condition. Okay, so the given data is acceleration is given as 3 meter per second square. Then the mu coefficient of friction is given as 0.25. Okay, then you have to apply here the equilibrium condition. The first equilibrium condition, summation of Fy equal to 0. So apply this equilibrium condition to this figure. Upward direction N minus this weight W, downward direction, minus P sin 30 is equal to 0. So from this we can get the value of N is equal to 1 plus P upon 2. Sin 30 is half, that's why the value of N. Put this as equation number 1. Then as we know that the F is equal to mu into N. Mu is given as 0.25 into N is 1 plus P upon 2. Okay, so apply the second equilibrium condition, summation of Fx equal to 0. So summation of Fx equal to 0. So horizontal force P cos 30, which is in positive x-axis, minus F minus M into A. M is here, M into A, that is D'Alembert's force or inertia force, that is A upon 9.81 is equal to 0. So here acceleration is given as 3 meter per second square, and the F, that is frictional force, from equation 2 we can put the value of frictional force here, and we can get the value of P by rearranging the terms as 0.561 kilonewton, that is required to find out. Okay, then we'll solve another problem based on this, that is the two bodies weighing 300 Newton and 450 Newton. The two bodies are hanged to the end of the rope passing over an ideal pulley. The pulley is shown in figure. With what acceleration the heavier body comes down, that is you have to find out the acceleration A, and what is the tension in the string. You have to find out the also tension in the string. Okay, so first we will draw the free body diagram for this block weighing on the the block on the over the pulley. That is the first of all we will draw the 300 Newton. Let us say the 300 Newton, that force, the block is moving in downward direction, so the self weight will be 300 Newton, which is in downward direction. The tension in the rope, that is T. We assume that the body is, so here another body that is for having 450 Newton. Okay, the tension in the string. Okay, so first of all, we assume that the 450 Newton body block is moving in downward direction. So the inertia force is in opposite direction, that is m into a. So here m is mass, that is here weight W is given. M here is W upon 9.81 multiplied by the a. So as the 450 Newton block will be moved in downward direction, the 300 block will be moved in upward direction. So to keep that it is in equilibrium, we apply this D'Alembert's force or inertia force as M 300 divided by 9.81 multiplied by the A. So we apply the equilibrium condition for this 300 Newton and 400 Newton block. So first of all, we apply the equilibrium condition for the 300 Newton block. So that will be upward direction T positive minus 300 divided by 9.81 into A. Then minus 300, the weight is equal to 0. Therefore, from this we can get the value of T as 300 plus 300 divided by 9.81 multiplied by A. So put this as equation number 1. So apply the equilibrium condition for the 450 Newton block. So there is no horizontal force. We apply the second equilibrium condition, summation of Fy equal to 0. So T upward positive minus 450 divided by 9.81 into A. Okay, so that is, so it is also in upward direction, so that is positive, minus the 450 Newton, the weight is equal to 0. So we can put the value of T from equation 1 into this equation. You can get the value of acceleration of A as 1.962 meter per second square. Okay, so that is we have to find out. The next, we have to also find out the tension in the string. So we can put the value of acceleration in any one equation or equation 1, then you can get the value of tension in the string as 360 Newton. Okay, so these are the problem based on the D'Alembert's force or inertia force or D'Alembert's principle.